Assalamu alaikum dear students. In the previous class we have done some questions of exercise 11.2 regarding three-dimensional geometry, and these questions were all about the equation of line in 1.4, direction cosinus and direction ratios of parallel and perpendicular lines. Now we are on the same exercise and we are on question number 7 of that exercise 11.2, and in that question number 7 we have a given line, and that given line has been expressed in terms of the Cartesian equation, that is x minus 5 divided by 3 is equal to y plus 4 divided by 7, and that's equal to z minus 6 divided by 2. That is the given Cartesian equation of the line, and we need to find the vector equation of the line. So since this equation is of the form x minus x1 divided by a is equal to y minus y1 divided by b, and that's equal to z minus z1 divided by c, where x1, y1, z1 are the coordinates of the given point through which the line passes, and a, b, c are the ordered three tuple of a, b, c are the direction ratios of that vector which is parallel to the line. And the equation of this line in vector form will become r vector is equal to a vector plus t times v vector. So in that equation we need a vector, that is the position vector of given point through which the line passes, and v vector, that is a vector which is parallel to the line. So since the equation is x minus 5 divided by 3 equal to y plus 4 divided by 7, and that's equal to z minus 6 divided by 2. On comparing this equation with the equation of line in Cartesian form, we will get this line passes through the point 5, minus 4, 6 and is parallel to a vector with direction ratios 3, 7 and 2. तो यहाँ पे mention कर देंगे the given Cartesian equation, the given Cartesian equation of the line is yes, x minus 5 divided by 3, and that's equal to y plus 4 divided by 7, which is equal to z minus 6 divided by 2, right? So this line passes through the point, because x minus x1 5, x y minus y1 so minus 4, and z minus 6 so that is z minus z1, that is 6. This line passes through the point yes, कौन से पॉइंट में पास हो रही है? 5 minus 4 6, 5 minus 4 6. जब इस पॉइंट में से ये पास हो रही है, लेकिन वेक्टर फॉर्म में हमें पॉइंट का पोजीशन वेक्टर चाहिए, सो हम पहले इस पॉइंट का पोजीशन वेक्टर ले लेते हैं. दिस लाइन पासेस थ्रू द पॉइंट 5 minus 4 6 with its position vector, सपोज उसको डिनोट करेंगे a से, एंड दैट्स इक्वल यस, अगर पॉइंट के कोऑर्डिनेट्स 5 minus 4 6 हैं तो पोजीशन वेक्टर ऑब्वियसली बनेगा 5i minus 4j plus 6k. So 5i minus 4j plus 6k, and is parallel to a line and is parallel to a vector with direction ratios 3, 7 and 2, and is parallel to a vector v, suppose उस वेक्टर का नाम हम v रखेंगे, and is parallel to a vector v with direction ratios, and is parallel to a vector v with direction ratios, क्या होंगे उस वेक्टर के direction ratios? Ordered three tuple of 3, 7, so 3, 7, 2. That is, इसका क्या मतलब? वेक्टर v फिर किसके बराबर आएगा? अगर एक वेक्टर के डायरेक्शन रेशियो हैं 3, 7 and 2, डायरेक्शन रेशियोज आर नथिंग, दे आर जस्ट द स्केलर कंपोनेंट्स ऑफ अ वेक्टर. सो दैट इज, वेक्टर क्या बनेगा? अगर 3, 7, 2 इसके स्केलर कंपोनेंट है तो वेक्टर बनेगा 3i plus 7j plus 2k. दैट इज वेक्टर v इज इक्वल टू 3i plus 7j plus 2k. So मिला वेक्टर v, मिला वेक्टर a, so we can easily find the equation of line in vector form. Therefore, equation of line. Therefore, equation of the line, the given line, in vector form is. Therefore, equation of the given line in vector form is. तो इस इक्वेशन, इस लाइन की क्या इक्वेशन रहेगी वेक्टर फॉर्म में? शाबाश. R वेक्टर must be equal to A vector plus T times V vector, which further implies that R vector is equal to, put the value of A vector, that's 5y. So 5y minus 4j plus 6k plus T times, put the value of V vector, that's 3i plus 7j plus 2k. This would be the required vector equation of the line whose Cartesian equation is given. So, if a line has the Cartesian equation x minus 5 divided by 3 equal to y plus 4 divided by 7 equal to z minus 6 divided by 2, then the vector equation of that same line would be r vector is equal to 5i. So, the 5i minus 4j plus 6k plus t times some the scalar times, yes, 3i plus 7j plus 2k. So 3i plus 7j plus 2k. So from the vector equation or from the Cartesian equation you can directly locate the vector equation, and from the vector equation you can directly locate the Cartesian equation. तो अगर एक लाइन की वेक्टर इक्वेशन 5i minus 6j r vector equal to 5i minus 4j plus 6k plus t times 3i plus 7j plus 2k, तो इस वेक्टर की कार्टेशियन इक्वेशन क्या बनेगी? x minus 5 divided by 3 is equal to y plus 4 divided by 7 is equal to z minus 6 divided by 2, right? So from the Cartesian equation you can directly locate the vector equation, and from the vector equation you can directly locate the Cartesian equation of the line. So that was all about question number 7 of this exercise. Now we are on question number next, that is question number 8 of this exercise. And in that question number 8, we have to find the equation of a line which is passing through origin O of 0, 0, 0. Obviously, origin has the coordinates 0, 0, 0 and A, 5, minus 2 and 3. So we have to find the equation of that line which is passing through 2 points, right? And for that we have deduced the article equation of line passing through 2 given points, both in vector form as well as in Cartesian form. तो क्या होती है vector equation of line passing through 2 points? R vector is equal to A vector plus T times B vector minus A vector. ये होती है उस लाइन की vector equation that passes through 2 given points, where R vector is again the position vector of any point on that line. A vector is the position vector of first point through which the line passes. T is a parameter, a real number. B vector is the position vector of second point through which the line passes. So that is the vector equation of a line passing through 2 given points. And the Cartesian equation of the line passing through 2 given points, that is x minus x1 divided by x2 minus x1, which is equal to y minus y1 divided by y2 minus y1, and that's equal to z minus z1 divided by z2 minus z1. These two equations we have deduced in the articles. So ये सब कुछ हमने पढ़ रखा है, ठीक है? अगर आप चाहोगे तो वो फिर से रिवाइज कर सकते हो. They are there on my channel, so you can review these concepts. आप फिर से इन्हें देख सकते हो. So R vector is equal to A plus T times B vector minus A vector is the position is the equation of a line passing through 2 given points in vector form, and x minus x1 divided by x2 minus x1 is equal to y minus y1 divided by y2 minus y1, and that's equal to z minus z1 divided by z2 minus z1 is the equation of that same line passing through 2 given points in Cartesian form, right? So here we are given, instead of x1 y1 z1 we have 0 0 0, and instead of x2 y2 z2 we have 5 minus 2 and 3, where you know x, y and z are the coordinates of any point on the line. x1 y1 z1 are the coordinates of first point through which the line passes, and x2 y2 z2 are similarly the coordinates of second point through which the line passes. So यहाँ पे सबसे पहले mention कर देंगे, given that a line passes through passes through the origin O of 0 0 0. सिंस सबसे पहले हम निकालेंगे इसकी वेक्टर इक्वेशन, और वेक्टर इक्वेशन में हमें चाहिए पॉइंट्स के पोजीशन वेक्टर्स. तो अगर ओरिजिन के कोऑर्डिनेट्स हैं 0 0 0, तो पोजीशन वेक्टर क्या आएगा? विद दिस पोजीशन वेक्टर एज यस 0i. सपोज उसको a से डिनोट कर लेंगे. a वेक्टर इज इक्वल टू 0i प्लस 0j plus 0k, and passing through the origin with its position vector as this, and point A, और point A में से पास हो रही है. सपोज इसका नाम हमने A रखा है और जिसके कोऑर्डिनेट्स हैं 5 -2 3. तो इसका पोजीशन वेक्टर क्या बनेगा? विथ दिस पोजीशन वेक्टर एज यस उसको बी वेक्टर से डिनोट करेंगे. सेकंड पॉइंट है, तो फर्स्ट पॉइंट का पोजीशन वेक्टर हमने ए से डिनोट किया, तो सेकंड पॉइंट का पोजीशन वेक्टर बी से डिनोट कर दिया. तो बी वेक्टर क्या बनेगा? 5y -2j प्लस 3k. राइट. सो हमारे पास ए वेक्टर आ गया, बी वेक्टर आ गया. सो वी कैन डायरेक्टली फाइंड द इक्वेशन ऑफ लाइन इन वेक्टर फॉर्म. देयरफॉर इक्वेशन ऑफ द लाइन Therefore, equation of the line in vector form is. तो क्या बनेगी वेक्टर फॉर्म में इस लाइन की इक्वेशन? यस, r वेक्टर इज इक्वल टू a वेक्टर प्लस t टाइम्स b वेक्टर माइनस a वेक्टर, which further implies r vector is equal to, put the value of a vector, that's 0i plus 0j plus 0k plus t times, put the value of b vector, that's 5y, so 5y minus 2j plus 3k minus a vector, that is 0i plus 0j plus 0k. So implies r vector is then equal to 0i plus 0j plus 0k, that is 0. लिखने से कुछ नहीं होगा, सीधे आएगा. yes, t times 5i minus 0i, फिर से 5i minus 2j, because minus 2j minus 0j is minus 2j, so plus 3k minus 0k, that's again plus 3k. So this would be the required vector equation of the line. We are keeping this line as keeping this equation as equation number first, which is the required vector equation. अब हमें चाहिए इस लाइन की कार्टेशियन इक्वेशन, और एक सिंपल सा मेथड है. एक वेक्टर इक्वेशन में से हम कार्टेशियन इक्वेशन कैसे निकालेंगे? डायरेक्टली हमें इस r वेक्टर का वैल्यू लेना पड़ेगा. तो r वेक्टर क्या होता है? पोजीशन वेक्टर ऑफ एन अननोन पॉइंट, पोजीशन वेक्टर ऑफ एनी पॉइंट. सो एनी पॉइंट के कोऑर्डिनेट्स अननोन कोऑर्डिनेट्स होते हैं, और वो हम लेते हैं x y z. तो अगर r वेक्टर जो है पोजीशन वेक्टर ऑफ अननोन पॉइंट है, अननोन पॉइंट के कोऑर्डिनेट्स x y z है, तो ऑब्वियसली उसका पोजीशन वेक्टर xi plus yj plus zk बनेगा. सो पुट हियर, नाउ फ्रॉम फर्स्ट वी हैव, now from equation first we have, what we have from equation first? Yes, r vector is equal to, r vector का वैल्यू xi plus yj plus zk, and that must be equal to, t से मल्टीपल कर दो तो 5 into ti, that's 5 ti, right? Minus 2 into tj, that's minus 2 tj, minus 2 tj, yes, and finally we have t into 3k, that's plus 3tk, because r vector is equal to this xi plus yj plus zk, position vector of an unknown point, and the unknown point has the coordinates x, y, z. So its position vector must be xi plus yj plus zk. Implies this can be further written as, yes, LHS में हमारे पास एक वेक्टर है रिप्रेजेंटेड इन टर्म्स ऑफ कंपोनेंट्स, RHS में हमारे पास एक वेक्टर है अगेन रिप्रेजेंटेड इन टर्म्स ऑफ द कंपोनेंट्स. When two vectors are represented in terms of their components and they are equal, so their corresponding components must be equal. So equating the corresponding components, equating the corresponding components को equate कर दो on both sides. On both sides we get, हमें क्या मिलेगा? Yes, x must be equal to 5t, so x is equal to 5t, y is equal to minus 2t, y is equal to minus 2t, yes, and z is equal to 3t, so z is equal to 3t. Clear? From here we can write implies, yes, x divided by 5 is equal to t, so x divided by 5 must be equal to t. Y divided by minus 2 must be equal to again t, and z divided by 3 must be again equal to t. Right? So x divided by 5 is equal to t. T and t RHS is same है, तो LHS must be same. So implies यहां से क्या मिलेगा? ये x है तो इसको लिख सकते हैं x minus 0 divided by 5. So 5 is equal to, या ऐसे भी लिख सकते हैं 5 minus 0. Clear? Similarly आपके पास y divided by minus 2 है तो लिख सकते हो y minus 0 divided by minus 2 है तो लिखोगे minus 2 minus 0, and that's equal to z by 3 means z minus 0 divided by 3 minus 0. So this would be the required equation of a line passing through 2 points. Point or O, origin 0, 0, 0 and A 5 minus 2, 3. So which is the required equation of line in Cartesian form? Which is the required equation of line in Cartesian form? ये होगी उस लाइन की इक्वेशन इन कार्टेशियन फॉर्म which is passing through origin O of 0, 0, 0 and A 5 minus 2, 3. Now again, this was question number 8, and in question number 9 we have instead of origin we have a different point. Suppose this is A of, it has the given coordinates, and here it is B, it has some other coordinates. तो A की coordinates अलग से दे रखे हैं, B की coordinates अलग से दे रखे हैं, and you need to find the equation of that line both in vector form as well as in Cartesian form. तो obviously you have to follow question number 8. बिल्कुल इसी तरह question number 8 और 9 में सिर्फ ये डिफरेंस है, 8 में हमारे पास origin था 0, 0, 0 और एक पॉइंट था, और यहाँ पे दो डिफरेंट पॉइंट्स हैं. तो बिल्कुल आप इसी तरह पहले वेक्टर इक्वेशन निकालोगे और वेक्टर इक्वेशन में आर वेक्टर का वैल्यू पुट करोगे xi plus yj plus zk, and there you will get the Cartesian equation of the line. So question number 9 is just the mirror reflection of that question number 8. So you can do it yourself. Now we are on question number 10 of the same exercise, and in that question number 10 we have been asked that we have two given lines represented in terms of their vector equations. First one is r vector is equal to 2i minus 5j plus k plus lambda times 3i plus 2j plus 6k. This is the equation of first line, and the equation of second line is r vector is equal to 7i minus 6k plus mu times I plus 2j plus 2k, and you need to calculate the angle between them. Since अगर हम इन दो लाइन्स को कंपेयर करेंगे with the equation r vector is equal to a vector plus t times v vector, then the value of a1 must be 2i minus 5j plus k, and the value of a2 must be 7i minus 6k. The value of vector v here in case of first line v1 3i plus 2j plus 6k, and vector v in case of second line, that is v2, that is I plus 2j plus 2k. We need to calculate the angle between these lines. सिंस इफ थीटा इज द एंगल बिटवीन टू लाइंस, पढ़ा है हमने जिगरा, अगर आपके पास दो लाइंस हैं लाइक दिस, तो सपोज इस लाइन की इक्वेशन, ये लाइन फर्स्ट की, ये लाइन फर्स्ट है और आपके पास ये लाइन सेकंड है, तो लाइन फर्स्ट की इक्वेशन है आर वेक्टर इज इक्वल टू 2i माइनस 5j प्लस के प्लस लैम्डा टाइम्स 3i प्लस 2j प्लस 6k. That is, line first is passing through the point with position vector 2i minus 5j plus k and is parallel to the vector. इसके parallel जो वेक्टर होगा वो वेक्टर क्या होगा? Yes, सपोज इनके बीच में थीटा एंगल है, तो वो वेक्टर क्या होगा? 3i प्लस 2j प्लस 6k. सिमिलरली वेक्टर v2 के अलोंग जो पैरेलल वेक्टर होगा लाइन 2, लाइन सेकंड जो आपके पास है, उसके अलोंग जो वेक्टर पैरेलल होगा वो क्या होगा? i प्लस 2j प्लस 2k. अगर इन वेक्टर्स को हम प्रोड्यूस कर देंगे तो डेफिनेटली अगर थीटा दो लाइन्स के बीच में एंगल है तो थीटा ऑब्वियसली दो वेक्टर्स के बीच में एंगल है. सो द इफ थीटा इज द एंगल बिटवीन लाइन्स फर्स्ट एंड सेकंड, then theta is the angle between their parallel vectors v1 and v2. and दो वेक्टर्स के बीच में जो एंगल है that we have learned किसके बराबर होता है वो? by that's calculated by the expression cos theta is equal to v1 dot v2 dot product of the vectors divided by product of the respective magnitudes, that is magnitude of v1 into magnitude of v2, right? So if theta is the angle between line first and line second, then theta is the angle between their parallel vectors v1 and v2, where v1 is 3i plus 2j plus 6k and v2 is i plus 2j plus 2k. Clear? तो यहां पे मेंशन कर देंगे the given equations of the lines are, the given equations of the lines are, this is the first part of question number 10. Yes, what are they? R vector is equal to 2i minus 5j plus k plus lambda times 3i plus 2j plus 6k. This is our line first. And similarly we have line second. R vector is equal to 7i minus 6k plus mu times I plus 2j plus 2k. We will keep this line as line number second. So the line first passes through the point with position vector 2i minus 5j plus k and is parallel to the vector v1 3i plus 2j plus 6k. The line first passes through the point, yes, और डायरेक्टली हम ये भी लिख सकते हैं द लाइन फर्स्ट इज पैरेलल टू द वेक्टर, पासेस थ्रू द पॉइंट की जरूरत यहां पे हमें नहीं है, तो डायरेक्टली द लाइन फर्स्ट इज पैरेलल टू द वेक्टर v1, सपोज उसका नाम v1 रखेंगे, टू द वेक्टर v1 और उसका स्ट्रक्चर क्या है? 3i प्लस 2j प्लस 6k, राइट? और इसी तरह जो लाइन सेकंड है दैट मस्ट बी पैरेलल टू द लाइन आल्सो. द लाइन सेकंड इज पैरेलल टू द वेक्टर. Line second must be parallel to the vector, yes, because it is of the form r vector is equal to a vector plus t times v vector, where v vector is the vector that is parallel to the line. तो क्या होगा वो? सपोज उस वेक्टर का हम नाम यहाँ पे v2 रखेंगे and that must has the structure I plus 2j plus 2k. Is that clear? Now if theta is the angle between line first and second, then obviously theta is the angle between the vectors v1 and v2. Now if theta is the angle, between lines first and second, Now if theta is the angle, suppose theta is the acute angle हम consider कर लेंगे, इनके बीच में suppose angle है, वो acute angle है और वो हम फिर calculate करेंगे. Now if theta is the acute angle between the lines first and second, acute क्यों? क्योंकि हमें यहाँ पे cos theta एक्चुअली लाइनस में प्लस माइनस भी हो सकता है, पढ़ा है हमने एंगल बिटवीन टू लाइनस में. तो ये माइनस साइन को एलिमिनेट करने के लिए हम सिर्फ पॉजिटिव वाला पोर्शन इसमें देख लेंगे. तो इसीलिए हमने मेंशन कर रखा है एक्यूट, क्योंकि जब ये एक्यूट होगा इट मस्ट बी लेस देन 90. व्हेन if it is less than 90, obviously it would lie in the first quadrant, and in the first quadrant all the 6 trigonometric ratios are positive there, so cos theta must be positive. Now if theta is the acute angle between the lines first and second, then theta is the angle between, then theta is the acute angle between vectors v1 and v2, and is given by the expression, yes, the cosine of angle between two vectors is equal their dot product, that's v1 dot v2 divided by magnitude of vector v1 into magnitude of vector v2. यहाँ पे plus sign because we have taken theta is an acute angle, right? So cos theta is equal to v1 dot v2 divided by magnitude of v1 into magnitude of v2, which further implies that this can be written as cos theta must be then equal to v1 dot v2. v1 is a vector expressed in terms of the components, v2 is a vector again expressed in terms of components. When two vectors are expressed in terms of their components, then what is their dot product? Sum of products of their corresponding rectangular components. And 3 into 1 plus, yes, 2 into 2, so 2 into 2 plus 6 into 2, sum of products of their corresponding rectangular components divided by magnitude of vector v1. magnitude किसके बराबर होता है? non negative square root of sum of squares of the scalar components, that is 3 square plus 2 square plus 6 square. 3 square plus 2 square plus 6 square into square root of, yes, magnitude of v2, so non-negative square root of sum of squares of scalar components of vector v2, that is 1 square plus 2 square plus 2 square. So 1 square plus 2 square plus 2 square implies this can be written as, so that implies cos theta is equal to, yes, 3 into 1, that's 3, 2 2s are 4, and 6 2s are 12. 12 plus 4, 16, 16 plus 3, that is 19, divided by square root of 6 square is 36 plus 2 square is 4, 36 plus 4 that is 40, 40 plus 3 square that is 9, so 40 plus 9 is 49, into square root of, yes, 4 plus 4 that is 8 plus 1 is 9. So implies cos theta must be equal to 9 divided by square root of 49 is 7 and square root of 9 is 3. So implies cos theta must be equal to 19 divided by 21. Clear? So this 19 divided by 21 must be a real number which must lie in the closed interval, that must lie in the closed interval minus 1 comma 1, and that is the domain of cos inverse. So its image definitely will lie in the range of cos inverse, means at that time it will become the principal value of cos inverse, and operating cos inverse on both sides, cos inverse and cos will become identity function, बचेगा theta, so theta must be equal to, यहाँ पे आएगा cos inverse of 19 divided by 21. So the angle between two lines which are represented by the equation this and this must be cos inverse of 19 divided by 21. So cos inverse of 19 divided by 21 must be the angle between these two lines which are represented by the vector, by their respective vector equations. Clear? So that was all about question number 10. Now lies the second part of question number 10, and that's again you have to find again the angle between two lines which are again represented by the vector equations. फिर से इसी तरह की दो वेक्टर इक्वेशंस हैं और आपको चाहिए उनके बीच में, उन लाइंस के बीच में एंगल. तो बिल्कुल आप इसी तरह अप्रोच करोगे, जस्ट द मिरर इमेज ऑफ दिस वन. So solve that part second by yourself, and that's all about question number 10 of this exercise.